Hello students. Today we're going to look at section 5.1, which is solving inequalities. Now an inequality is a number sentence that doesn't have an equal sign, but instead it has an inequality symbol, like less than, greater than, less than or equal to, greater than or equal to. Those are the four choices of inequalities that we're going to do. So we're going to look at solving inequalities and then how to graph them on a number line. Much of this is going to be familiar because you solve an inequality just like you solve an equation. You just have a different symbol in the place. Okay? So let's practice a few of them. The first one I have is x minus 12 is greater than or equal to 8. In order to solve this, I need to get x by itself, so I would have to add 12 to both sides. So I add 12, x is greater than or equal to 20. Simple as that. But now we need to graph that on a number line so that I can show that all of my answers are going to be greater than or equal to 20. Okay? So I'm going to draw a number line, simple number line. I'm going to put the number 20 right here. Okay? And I'm going to use a different color to do my graph just so you can see the separation. Now this says greater than or equal to. That means that 20 is one of the numbers that's a solution to this inequality. So I'm going to use a closed dot. The closed dot means that 20 is a part of the solution set. Okay? So now I need to tell me that all of my x's are greater than or equal to 20. So I need to shade which part of the number line is greater than or equal to. Well, we know that greater than or equal to is to the right. So I'm going to draw a heavy arrow like that. Notice that my arrow is on the number line. And I know sometimes when you use pencil, it's kind of hard to tell the pencil and the pencil. You can just make it a little bit darker. You don't have to go crazy. But notice that now the purple line represents all of my solutions, the number 20 and everything greater than 20. So let's look over here at my next one. My next one says 22 is greater than m minus 8. Well, I want to do the same thing. In this case, so m is on the right-hand side instead of the left. So we need to solve first, and that means I need to add 8 to both sides. And so I get m is less than 30. Now here's the tricky part. Whenever we read an inequality statement, we always have to start with the variable. In this case, the variable is on the right-hand side, so I'm going to start reading it like this. M is less than 30. And you're thinking, wait, Mr. Cohen, is that sign is a greater than sign? You're right, it is a greater than sign if you read it 30 is greater than m. But I'm not reading it that way. I'm reading it as m is greater than 30. Now I could flip it around if I want to, but I can't just flip sides. I have to flip the entire thing around. So I could also write it as m is less than 30. Notice that the less than symbol is pointing to m in both cases. That's very, very important. Because if not, it changes the entire answer and it'll be wrong. Okay? So in this case, m is less than 30. So I'm going to draw my number line. And on my number line, I'm going to put the number 30. And in this case, it just says m is less than 30. It doesn't say less than or equal to, it's just less than. That means 30 is not a part of the solution set. So I have to identify on the graph that 30 is not a part of the solution set. So I'm going to use an open circle. That open circle tells me I'm starting at 30, but 30 is not one of my solutions. And I need to go less than 30, so I'm going to draw an arrow to the left, heavy arrow, and put my another arrow there. And that lets me know that m is less than 30. Because everything that's shaded on the number line is at 30 or less than 30 because 30 is not included. Sorry about that. Okay? So let's look at the last example. D minus 14 is greater than or equal to negative 19. Again, I've got to get d by itself, so I'm going to add 14 to both sides. Well, that's not a 14. Plus 14, plus 14. So d is greater than or equal to negative 5. Okay? Draw my number line, put negative 5 on my number line. In this case, it says that d is greater than or equal to negative 5. So negative 5 is included, which means that I have to use a closed dot. So I'm going to put a closed dot. I'm going greater than or equal to, so I'm going to draw an arrow to the right. And that is my solution. I simply solve, and then I graph on the number line. Before we move on from these problems, I want to talk to you about another way that you might see this answer, and that's called set builder notation. It's supposed to be a dash there. Set builder notation. Set builder notation is a concise way of telling me what my solutions are. And it's in brackets, so I will write a loop, arrow loop. And for instance, we're going to start with the first one in red, so why don't I write it in red? That would be a good idea, Mr. Coens. Thank you so much. So the first one in set builder notation, I draw my brackets, and I'm using X, and then I draw a line, a vertical line, so that X is greater than or equal to 20. Whoops, that's supposed to be a bracket. And this is red, X, such that X is greater than or equal to 20. You might also see it, the set of all numbers X, such that X is greater than or equal to 20. So this line stands for such that. The set of all X's such that X is greater than or equal to 20. Another way to say all the X's are greater than or equal to 20. So let's write this purple one in set builder notation. I'm using the letter M, so I do M such that M is less than 30. Red again, all numbers M such that M is less than 30. And the last one in orange is D, brackets, such that D is greater than or equal to -5. Okay? Again, all the letters D such that D is greater than or equal to -5. That's set builder notation. Sometimes your instructions will ask you for set builder notation. Sometimes you will just see your multiple choice answers in set builder notation. You just need to know that that is another way to give the solution. Here's one more example that I want to make sure we understand because it's been a long time since we solved equations with variables on both sides. So I've got 3a plus 6 is less than or equal to 4a, and I need to solve this inequality. So remember, when we have variables on both sides, we always start with the smallest one. Very, very important with inequalities. So I'm going to start with the 3a. What do I need to do with the 3a? Yes, exactly. I need to subtract 3a from both sides because it's the smallest variable. That's what I start with. This goes away. 6 is less than or equal to a because 4a minus 3a is just a. Now, I could rewrite that if I wanted to, but again, if I do that, I have to flip the entire inequality statement, not just the two sides. A is greater than or equal to 6. Graphing it, number line, 6, greater than or equal to, closed dot, greater than or equal to, so I go to the right. There's my graph. And now let's put it in set builder notation. A such that A is greater than or equal to 6. Nothing new, just wanted to make sure you remember how to solve the inequality with variables on both sides. Now what if we're given a word problem and we have to write an inequality statement from it? That's what we're going to do. So I'm going to give you a second to write this down. The sum of twice a number and 5 is at most 3 less than the number. Okay? Back when we were doing this, when we did equations, you remember I always wanted to look for the word is, which was my equal sign. Well, in this case, I don't want to find is first because, well, there's an is. But it's not just is, it's at most. So I'm going to underline that. Is at most. Okay? At most is less than or equal to. So I know that's going to be my inequality statement. Why is it less than or equal to? Because at most, that's the highest it can be. Everything else has to be under it. Okay? At most, highest number can be. All of my other solutions have to be under that. That's why it's less than or equal to. So let's check what's on the left-hand side of this. The sum of twice a number and 5. Twice a number and 5. Twice a number, I'm going to use n because you know I like to use n. 2n, twice a number, and 5 is at most 3 less than the number. Uh-oh, we have that less than. That means the 3 has to come after the n. I've got less than, so that means minus. It doesn't say is less than, is less than is an inequality symbol, but this just says less than, so that's minus. So n minus 3. And there's my inequality statement, 2n plus 5 is less than or equal to n minus 3. What do I do? Start with the smallest variable. Smallest variable is n. So I'm going to subtract n from both sides. So I have n plus 5 is less than or equal to negative 3. Subtract 3 from both sides. Why did I do that? It's supposed to be subtract 5 from both sides. That's what happens when it's early on a Monday. So n is less than or equal to negative 8, because negative 3 minus 5 is negative 8. So my answer is n is less than or equal to negative 8. In set builder notation, all answers n such that n is less than or equal to negative 8. Graphing, draw my number line, give me a negative 8. It's less than or equal to, so that's a, yes, a closed dot. Less than, I go to the left, draw a heavy arrow, and there it is graphed. So what all today is about is writing, solving, and graphing inequalities. So here are your 3 practice problems for today, for this video. 1, solve and graph p plus 8 is less than or equal to 18. Solve and graph 6x plus 5 is greater than or equal to 7x. And then write the inequality, then solve and graph twice a number is more than the sum of that number and 9. Once you have those practice problems finished, take a picture of them and submit it through Edmodo.